Okay, homework number 10. Here we're going to continue with graphing, and we're going to be working on getting equations from facts. Last time we had the equations and we just had to graph them. This time we actually get some clues about how the equation looks, and we're going to actually figure out the equation and then graph it. Okay, question number 1. Find the equation for a line with a slope of 3 that passes through the point 1, negative 3, and then go ahead and graph the line. Well, of course, we're always going to try to put all of these equations in y equals mx plus b form. So let me write that on top over here so we don't forget that. M, of course, being the slope, and the b being the y-intercept. Now, for number 1, we are told what the slope is. The slope is 3. We do not know the y-intercept, so the way we're going to calculate that is simply by using the point that we were given to plug it in. We know that every line is y equals mx plus b. Now, our slope is 3, that we know, and we can plug in these values to get the b. So for the y, we'll plug in negative 3, since we're given that. For the m, we will plug in 3, because we're given that also. We're given that the slope is 3. And for the x, we will plug in 1, because we're given that as an individual point, plus b. And now we simply solve for b. And so really we've got negative 3 equals 3 plus b, and subtract 3 from each side in order to isolate b, and you've got b equals negative 6. Subtract it from this side, subtract it from that side, you've got b equals negative 6. Which overall means that our equation is y equals mx, and the m we know is 3, plus b, and the b is negative 6, which gives you minus 6. So that's our equation. Now, we could graph this by using the same system as we did before, making the charts. This one I'm going to do a little quicker because we've already done it, and because you should probably learn how to do this as well. First, we can do and the way you can do this simply without going through those whole charts is to first plot the y-intercept, which is negative 6. So 1, 2, 3, 4, 5, 6. Here is the y-intercept. And then we can use the slope, which is always rise over run, to figure out other points. It's 3, so that means up 3 for every 1 over. 1, 2, 3 over 1, 1, 2, 3 over 1, 1, 2, 3 over 1, and we could really do this as often as we like. And then we go ahead and draw the line, which I'll start over here. And that is our line. Of course, we could put arrows on the ends, write the equation if we like, but this will be the line. Okay, that is number 1. Now let's do numbers 2 and 3. Okay, there we go, blank board. Let's do the next 2 in the same way. Find the equation for the and slope for a line that passes through the points 1, 4, and negative 2, 10. Now over here we don't know the slope, but we can figure out the slope. The slope is the change in y divided by the change in x. Now, change in y means the second y minus the first y, or the first y minus the second y, as long as you're consistent about it. So let's figure that out. Let's take the 2 points. Now, in these points, the change in y is 10 minus 4. What's the difference between 10 and 4? Well, 10 minus 4 is, of course, 6. Divided by the change in x, negative 2, 1. That's negative 2 minus 1, which is negative 3. Again, as long as we did it in the same direction, we did 10 minus 4 on top, so on the bottom we'll do negative 2 minus 1. We could have also done 4 minus 10 and 1 minus negative 2. That would have given us the same answer. Either way, 6 divided by negative 3 is negative 2. Now we've got the slope of negative 2, and then we can figure out the b using the same thing as we did in the previous example. Just plug it in. We can use either point, so let's use the first point. Looks a little simpler. Y equals mx plus b. So the y for this would be the 4. Negative 2 is the m. X is the 1 plus b. So that's 4 equals negative 2 plus b. Add 2 in order to isolate the b. Add 2 to each side, and you've got the b equals 6. Which means the equation is y equals mx, and the mx is negative 2, negative 2x, plus 6. That is our equation. And let's graph it the same way. Plus 6 is the y-intercept, so along the y-axis, 1, 2, 3, 4, 5, 6. Let's put this up here. The slope is negative 2, which means 2 down 1 over. 2 down 1 over. 2 down 1 over. And this is going to be our line. Let's draw it using our straight edge. We'll start it from up here. And that is our line. Okay, let's take a look at the next one. And to do that, we'll just put a little fresh graph paper here. Sorry, I cut off a little bit from the previous question, but hopefully you remember that. Okay, and number 3 is really the same idea as number 2. Let's try it in a new color to be a little less confusing. We've got 2 lines, and once again, we have to figure out the m first. We have to figure out the slope first, which is the change in y divided by the change in x. So the slope, again, let's use this first. I'll draw it out this time. 5 minus negative 7 divided by negative 2 minus 0. And that means that 5 minus negative 7 is 5 plus 7, which is 12, divided by negative 2 equals negative 6. So the slope is negative 6. Now let's plug it in. Y equals mx plus b in order to figure out the b. We can use either one. Let's try this one. Y equals, we'll take that as negative 7, equals mx. Our m is negative 6, and our x is 0. Plus b, and this is the same thing as saying, well, negative 6 times 0 is 0, which negative 7 is b. Now, of course, we also, and so our y equals mx plus b is y equals negative 6x minus 7. And of course, another thing we could have done is we could have just taken, we knew that the point was 0, negative 7, so we know that inherently that is the y-intercept. So let's plot 0, negative 7. Which is down here. Now I can't, the slope is negative 7, so if we'd have to go down 7, 1 over, or we can just go the other direction. In the left side, we can go up 7. So left 1, up 7. The slope is still going to be in the same way. 2, 3, 4, 5, 6, 7. The slope is still going to go down, but of course we couldn't do it in this direction because we would have run out of room. And let us go ahead and plot it. We'll start from here and go down this way, and that is our line. And now for the last part of homework 10. Number 4 is kind of like the ones that we just looked at. Find the equation for a line with a slope of 1/2 that passes through negative 1 and 3. So we know that the slope is 1/2. I'm going to use 0.5. It's just a little cleaner that way. And we don't know the b, so we'll figure it out. We got y equals mx plus b. We'll use this point that we were given. So the y we'll use as 3 equals the slope, which is 0.5, times x, which is negative 1, plus b, which is 3 equals negative 0.5 plus b. Add 0.5 to each side, and you've got b equals 3.5. Let's graph it. Oh, well, first of all, let's write our equation. Y equals 0.5x plus 3.5, because that's our y-intercept. Let's graph our y-intercept over here, and our slope is 1/2. So that means a half up for every 1 over, which means 1 up, 2 over. Well, we can do the first one. A half up, 1 over. And then we can do, let's say, 1 up, 2 over, 1 up, 2 over, which is the same thing as a half up, 1 over, and then we can just go ahead and draw the line. All right, very good. Number 5, let's quickly go to that one. I'll use a different color here. Find the distance of the line segment that goes from 0,2 to 1,7. So we don't even have to draw this, but I think it's a little easier if we draw it out. So 0,2 is over here. And 1, 7 is 1, 2, 3, 4, 5, 6, 7 up here. So we're talking about the distance of the line segment that goes from here to here. Okay. If it were flat, you could just count the number of boxes. Unfortunately, you can't do that, and there are two ways to do it, and they're really the same way. The first way, the one that's most, I guess, algebraic, is applying the distance formula. Distance formula is the square root of the difference in x squared plus the difference in y squared. y2 minus y1 is the same thing as the difference in y. So let's apply that. So let's take our second x is 1 minus 0 squared. And then we've got 7 minus 2 squared, which is the distance equals 1 squared, which is 1, plus 5 squared, which is 25. And so our difference is the square root of 26. Now, how would we figure that out? What's the other possibility? The other possibility is simply imagining this as a right triangle and then using the Pythagorean theorem, which is really the same thing. You know, if you imagine this is a right triangle going from here and then up here, then the red line would be a squared plus b squared equals c squared. And this direction would be 1 squared. Plus this direction would be 1, 2, 3, 4, 5 squared equals c squared. 1 squared plus 5 squared is 26 equals c squared. So c would be the square root of 26, which is the same thing we got. Really, these two things are the exact same thing. One is just writing it out, and the other is writing a little bit less of it out. But it's the same idea. All right, third one. Similar problem, except now we are asked to find the perimeter. 4 corners, 1, 2, which is here, 7, 2, which is 1, 2, 3, 4, 5, 6, 7. One second, 1, 2, 3, 4, 5, 6. I'm sorry, that's too far. 1, negative 4, 1, 2, 3, 4, and 7, negative 4. Now, this is actually an easy one because all the lines are flat. You don't even have to use the distance formulas. Let's draw the rectangle, it looks like, over here. You don't even really need a graph to do this, but I think it's a little bit easier conceptually if you have it. All right. Now, a perimeter is simply an addition of all the sides. And here again, if you needed to use the distance formula, you could do it for all 4 sides and then add them all up. Here, you just count the boxes. Well, 1, 2, 3, 4, 5, 6 boxes this way. And then down here you got 1, 2, 3, 4, 5. Oh, this is also 6, so it's actually not a rectangle. I mean, it is a rectangle, but it's a special type of rectangle called, of course, a square. And a square is, the perimeter of a square is simply 4 times any side. And so, of course, the answer is 24. And that is the, well, it is a rectangle because a square is a type of rectangle, but it's also it's a square.